All right, guys, welcome back. Hope everyone had a really solid, good weekend. We've got 7 minutes until it's 11:30, so I'm just getting things underway a little bit in advance of the official start time. But welcome back, and I hope you guys are doing well. Yeah, we'll just get comfortable and start getting into our logic meeting in just a few. Hey there, guys. Good to see you. Feel free, anybody that's here, to just say hello, but I know that we only have a couple for now. Still a few minutes till class time, but hi, Rachel, Nathaniel, Arlene. Hope you guys are doing well and had a good weekend. Air's a little better, so that's nice. It's a little too much to have to deal with the pandemic and the bad air all at once, so at least we got the air back. Hi, guys. Hi, Valeria, Leo, Stephanie. Good to see you guys. So about 3 more minutes, and we'll just get right to it. Hey, Ruby, Brenna. Nice to see you guys. Hey, Josephine. Jamie. Yeah, good weekend overall. I watched some of the Emmys last night, but I gotta tell you, I was kind of surprised or like confused. This show, Schitt's Creek. You guys heard about that show? It seems like it won every award, but just based on the name alone, like I refuse to watch it. I don't know. Maybe it's good. Maybe you guys will tell me that it's an amazing show. But I kind of was a little bit bummed that like a show that I've never really watched and don't know anything about is like winning all the awards. It made me feel kind of out of touch. But if you recommend it, I'll check it out. It's just sort of like there's so many shows out there. How can one just be dominating everything? But okay. It's been out for so long though that it's one of those shows where I feel like for me to get into it now, I'm gonna be way behind. It's not like how many seasons are there? But yeah, it seems like the consensus among the logicians is that it is funny. So I'll check it out. What's up, Peach? Hopefully this girl doesn't get too involved in the lecture today. But you can see that she's definitely trying to get into my business. Hey, good girl. Little Peachy. So we still got about 30 seconds and then we'll get going. What's up, Peach? You want to go over there? Hello. Good morning, one and all. Nice to see everyone here. All right, so it's essentially now it's 11:30, so I'll go ahead and let us get started. Thanks all for being here. And let me just open with a quick question, touch base with you guys. Did you guys notice my message this morning with the answer key for the first homework? Just let me confirm with you that it came through. Okay, good. Yeah, so you can go ahead and use that as a reference for the corrected answers for your first homework. And for your individual score, just feel free to send me a quick message and allow me like a day or so at the most, and I'll give you a reply back where you get your score. So whenever you'd like it, just let me know and I'll send off your individual score, and I can give you comments on any of the questions that you might have missed. But you'll know those items by having compared your original submission to the answer key. Other than that, we just keep going forward. So there's another homework that I'm going to give you guys either later tonight or tomorrow morning. And so I'll send that through Titanium as well. And I'm going to just slightly adjust the due date for that to give everyone as much time as they need to, get a good assignment finished. So I believe when I'm looking at the syllabus right now, actually, let me quickly look at this. Sorry. Yeah, so it was scheduled to be due on next week, the 30th, but I'm just going to modify that till Monday the 5th. So it's going to be due in 2 weeks from today instead of next Wednesday. So you'll just get an additional weekend to complete the second homework. The second homework is going to be all about the symbolizations and translations that we're working on now, the second kind of major topic of this logic class. So you'll receive the next homework packet, and you get 2 weeks to work on it after I deliver it to you guys tonight. And since the first homeworks are all done, anybody can check with me for their score. I don't like to make a mass listing of scores like in the Titanium website itself, because I'm not always sure how secure it is, and I like to keep physical records because they can't be destroyed. So I have my own electronic and hard copy records of those, and just checking with me, you can find your score on this and any. Okay, so maybe I can make mention of some of the questions on the homework really fast. Since we're all here together, I think it's always good to sort of back up the answer key with a little in-class discussion. So just bear with me one moment while I pull up the homework. Yeah, okay, so I'm looking at it now, and I'm just reading off the different questions as I go down the list, and I'm going to talk to you guys about the correct answers. So, all right, first of all, the first section is a true-false section. And what the question asks is this statement true or is it false? And you have to kind of explain, in case it's false, why. So, all right, first of all, Question 1. If all the premises of an argument are true, the argument is valid. Is that a true or a false statement? Who could tell me? When the premises are all true, the argument's valid. Yes or no? True or false? Is just having true premises enough for it to be valid? Okay, so Ruby, Lily, false. Good. The correct answer is yes, false. But let's get an example why. Why is it that true premises do not guarantee validity? Can you give an example of an argument where the premises are true, but it's not valid? That would be the right type of information to state as an explanation for why the correct answer is false. So yeah, why is it false? Or can you give an example that makes it clear that in this example, the premises are true and nonetheless, it's not valid? Arlene, I'm not sure what you mean when you say 2 + 2 is 4. Oh, okay, so you're writing a whole argument out. How about this, just while we're in the chat, number premises and leave them in one blurb. So in case like another student writes something after you've hit return, it's all contained in one little text box. And just number the premises, and then we'll see what the argument looks like. But anyway, I see your example. 2 + 2 = 4, therefore Trump has been on the moon. Yeah, so that's not a valid argument, correct? The premise, I guess you're saying, is 2 + 2 = 4, therefore Trump has been on the moon. Obviously, it's possible for that argument to have a true premise and a false conclusion because the premise is true and the conclusion is false, so it's invalid. Can't have all true premises and a false conclusion according to the definition. Exactly. So suppose all the premises are true. That does not mean that it's valid necessarily. Maybe the conclusion is false, and in that case, it would be invalid. Or maybe the conclusion is true also, but the premises do not logically imply the conclusion. So although the premises and conclusion happen to be true, there's a possible world where the premises are true and the conclusion is false. Like, for example, the sky is blue, therefore Trump is the president. That's not a valid argument, although the premise and the conclusion is true. The reason it's not valid is because there is another possible world in which the sky is blue, but Trump is not the president. In that case, the premise would be true and the conclusion would be false. Since that's even possible, it's invalid. So, good. Let's go to number 2. All valid arguments are sound. Are they or not? Is every valid argument sound? If so, this is a true statement. And if not every valid argument is sound, then that's a false statement. So what's the correct answer, true or false? True or false to the statement that says all valid arguments are sound? Are they or not? Good, no, they are not all sound. Can one give an example of a valid argument which is not sound? A valid argument, but it's not sound. That will be an example that proves that 2 is a false statement, because 2 says every single valid argument is sound. So if we can even give one example of a valid argument that is not, then that means not every valid argument is sound. Okay, so Dran Reb, I'm seeing one statement that you wrote, which is that dogs are reptiles. Okay, where are you going to go from there? Even though you could feel free to put it all in one message, but that's okay. Yeah, okay. Valeria, athletes never get hurt. Okay, we know that's not true, but it could start off a valid argument. So let's just see how you go from there. Okay, so second premise, Destiny has played soccer. Okay, good. And therefore, you're drawing a conclusion? Therefore, Destiny has never been hurt. Okay, good. Now, that's a valid argument, isn't it? It is. Because what it says is, athletes, the whole category, do not get hurt. It follows by saying that one person named Destiny is a soccer player, in other words, and is an athlete. So from those two facts, or from those two statements, the information of the conclusion does logically follow. It follows that Destiny's never been hurt. But that's not sound, since premise 1 is clearly false, which says that athletes never get hurt. Athletes do sometimes get hurt, as we all know. Okay, good. Drown Red. Now I'm putting your different parts together. The first premise, dogs are reptiles. Second premise, all German Shepherds are dogs. Therefore, German Shepherds are reptiles. Good. So according to the premises, that is the conclusion that follows from them, yes. But, of course, the statement that dogs are reptiles is not true, so it's valid but not sound. Okay, perfect. So we're going to number 3. Every argument with a true conclusion is valid. Yes or no? Does every argument with a true conclusion become valid automatically? Yes or no? All right, correct, Ruby. False. Not every argument with a true conclusion is valid. Yeah. So can you give an example where there is a true conclusion, but the argument isn't valid? That would be the right kind of counter example here. Argument which has a true conclusion, so there's a fact at the bottom, but it's not valid. The reasoning of the premises does not establish this true conclusion. What could be an example like that? Let's see. We're just going to go through the whole homework problem set, make sure that's been totally clear. It's one thing to read it on a page, but it's also helpful, I think, to have a little video. Well, face-to-face would be perfect, but video or just audio-based communication to back that up. So let's get the example then of why question 3 is false, why that statement is false in question 3. Okay, so good, Arlene. Dogs are mammals, therefore Trump is the president. Very, very good. That's not a valid argument. But isn't Trump the president true? Yes. So the conclusion is true, but the premise doesn't prove the conclusion. In fact, it's not related to it at all. So could there be a world, could there be a universe in which dogs are mammals and Trump's not the president? Sure, because dogs being mammals does not imply that Trump will be president. So yeah, that's a very good example. An example where your conclusion is true, it's a fact, but the argument with those premises does not lead us to this fact. So the truth of the premise is irrelevant to the truth of the conclusion, which means that although the conclusion is true, it could have been false, even in a scenario where the premise is true. Okay, good. Nobody else? Gonna leave it to Arlene? How many of you are here? There's a lot of you here, but maybe people got it wrong. I don't know. If you have examples, then you could probably just put them out there, like the type of example from your homework. Maybe one more or not? I'll give it a second. Some of the other ones are pretty easy to generate, but and some of them will go pretty fast. But that's a fair example, Arlene, so good job with that. Do you guys understand what's being stated here? That just because the conclusion is true does not automatically make the argument valid. Okay, Ruby. Well, and Lily. So Lily, your argument is Dr. Vulich can read, and therefore Dr. Vulich is a professor. Good example. Yes, I'm a professor, and you guys know that because you're my student. But just because I can read, that does not imply that I'm a professor. It could have been that I learned how to read and just did not ever go to graduate school and become a professor. So although I read and I'm a professor, being able to read does not force the conclusion to be true. Ruby, all dogs are green. Poodles are dogs, therefore poodles are green. No, Ruby, wrong, incorrect. That's not the right example because in your example, the argument actually is valid. So the question says every argument with a true conclusion is valid. Since that's false, since that statement is false, to demonstrate its falsity, you have to produce an example of an invalid argument with a true conclusion. That type of example will show that not every argument with a true conclusion is valid, because in such a case, the conclusion is true, and it is an argument that's not valid. So you would have to give examples like some of these students where the premises don't imply the conclusion, nonetheless, the conclusion is true. Drawn red. Biden was vice president, therefore Biden is running for president. Good. That's also invalid, even though the conclusion happens to be true. Therefore, also, that's a fine example, Frida. Your premise is logically true, and your conclusion is just like logically indeterminate, but true. But in case you were not a student, then the premise would still be true and the conclusion false. Okay, great. So now question 4, let's talk about question 4. It says, if all the premises of an argument are true and the conclusion is false, then the argument is invalid. Is that true or false? Question 4. So, Leo, does the insufficient premises make it invalid? Which example, Leo? Yeah, so the correct answer for 4 is true, yes. And that's simply because the definition of invalid is an argument's invalid if it's even possible for the premises to be true and the conclusion false. So if the premises are actually true and the conclusion is actually false, that just fits the specific definition of invalidity, and that is an invalid argument. Leo, in the cases given above, like I can read, therefore I'm a professor, it's invalid because the premise can be true and the conclusion could have been false, okay? So any argument where the premises are compatible with the conclusion being false is invalid. Valid means that if we pretend the premises are true, then we would have to agree that the conclusion is also true. An invalid argument is where, under the conditions where the premises are true, it's still somehow within the realm of possibility for the conclusion to have been false, even if it is true. So, like, I'm from California, therefore I'm a professor. That's not valid because, yes, I'm from California. Yes, I'm a professor. But being from California doesn't guarantee that I would be a professor. So in another possible world, I'm born in California and, you know, I just do music and I'm not a professor at all. Since that possible world is a possibility, the argument is invalid. Okay, just to help you, Leo, with your question. But now let's continue through the list. The special cases of validity don't have to apply to this problem, but they may. It just depends on the case that you select. I noticed, Frida, that you gave an example where the premise was logically true, and that's good. But it could have been one of the other regular sounding examples like other students have given. You see what I'm saying? Because there are many ways for an argument to either be valid or invalid. They may make reference to a special case of validity, but they don't need to in every single case. So it's optional that they include reference to that in the first 4 problems. Okay, Brenna, if we got something wrong, would we get 0 out of 5 points? No, there's partial credit given. Yes, number 4, the answer is that number 4 is true, Arlene, correct. And then, yeah, if you missed a question, there's still a possibility for some partial credit depending on what kind of mistake that you made. So you don't necessarily get 0 out of 5. It's possible that you could, but it depends on whether you gave partially correct information or not. So partial credit's possible, yes. Okay, so now to number 5. It says, give an argument with these characteristics. So question 5 says, give an example where the argument's valid, but there's a false premise and a true conclusion. So let's see if you come up with something like that. What is one such example? So the argument must be overall valid. The conclusion is a logical product of the premises, regardless of the facts, whether they're facts or not. But give me such an argument where at least one premise is not a true fact, but the conclusion is. Okay, so Brenna, you and Arlene give these examples. All right, so Brenna, you're definitely giving one of those funky special cases of validity, which is like going to confuse some people, I think, because it requires you to think of only those 3 cases, right? But like in your example, Abraham Lincoln is alive, false. Obama has been the president, true. Therefore, a triangle has 3 sides, which is logically false. So, but you know what? Oh yeah, sorry, no, it's logically true. I'm sorry, I was thinking 2 + 2 is 3. No, yeah, a triangle does have 3 sides, which is logically true. Let's all be very clear about that. So in your example, good, Brenna, the conclusion, which is logically true, guarantees the validity of the argument overall, even though, you know, the overall argument has a false premise and a true conclusion. So that's one of the special cases of validity, fair enough. Arlene, here's your example. And this is the kind of example that'll probably make more sense to some. Arlene says, all mammals eat meat. Second premise, all humans eat meat. Therefore, humans are mammals. Ah, no, sorry, Arlene. Just because all mammals eat meat and just because all humans eat meat, it does not follow that humans are mammals, because you did not say only mammals eat meat. You said all mammals eat meat. So it could be that although all mammals eat meat, there are also things that are non-mammals that eat meat too. If you had said all and only mammals eat meat, from there, the statement that all humans eat meat would imply that humans are mammals. But all is a different word than only. It's possible for all mammals to eat meat, but not only mammals to eat meat. So your argument is invalid. even though it was a noble attempt, because the other aspects of the correct answer you did get. Like you gave a premise that's false, which is that all mammals eat meat. They don't all eat meat. And you also gave a conclusion which is true, which is that humans are mammals. But you're actually giving an invalid argument. Okay, Valeria. All animals have ears. Bunnies or chickens? Sorry, conclusion, bunnies have ears. Well, you're missing a premise though, because I don't know what a chicken is. You have to say that chickens are animals. And then if you had added that third premise, then combining all animals have ears, chickens are animals, and bunnies are chickens would imply that bunnies have ears. But you did not say that chickens are animals. So maybe chickens are, you know, pieces of furniture. And even though all animals have ears and bunnies are chickens, it doesn't follow that bunnies have ears because you didn't put the information that chickens are animals, which I don't know unless you say it. Okay, Lily. All humans are dogs. All dogs are mammals, and therefore all humans are mammals. Now that's a good example. It's valid, and the first premise is false, but the conclusion is true. So that's exactly what the argument asks for. Valid with a false premise and a true conclusion. Jamie, Leonardo DiCaprio is a man. All men are 6 feet tall, and therefore Leonardo DiCaprio is 6 feet tall. That's also a good example. Do you know his height? If it's actually 6 feet, then it fits our instructions, because then it's a true conclusion. And in the argument, there's the false premise that all men are 6 feet tall. So we are led to this conclusion logically by the two premises, but one piece of information of premise is false. Good. Presidents must be at least 35. Hillary Clinton's the president, and she's at least 35. Good. She is at least 35. She's over 70. And it's also a valid argument, but the second premise of the argument is clearly false. All right, perfect. So working through the examples, making a couple of little clarifications for some of us, that's the right kind of material to give for 5. Now 6, it says, give an invalid argument, all of whose premises are true and whose conclusion is false. Now that one is like, that's really giving it to you kind of a freebie, because there's no way to give an argument where the premises are true and the conclusion is false that's not invalid. Every single argument with all the true premises and a false conclusion is invalid. So, I don't know, does anybody have like a favorite example they could just put out there? It's just, if you just randomly select anything true and use it as a premise, and anything false and use it as the conclusion, then that would be a correct answer. So like, what could be one case? What do you think? What do you think on this one? So just, you know, I mean, quick example coming back from the group chat. Okay, so Jamie, 2 + 2 = 4. The sky is blue, and therefore horses can fly. Okay, yes, that would definitely be invalid. The premises are true, the conclusion is false. Fair enough. Drawn red. Trump is the president, therefore Bush is the president. Well, that's definitely invalid because the premise contradicts the conclusion even. So far be it from the conclusion being true when the premise is true. Certainly invalid. Good. Lily, all cats are animals. All rabbits are animals. And therefore cats are rabbits. Well, let me think about this. Cats are the animals, rabbits are animals. But yeah, so that's invalid. Just because cats are animals and rabbits are animals, it doesn't say that only cats are animals. So that would be invalid, but with true premises and a false conclusion. Love it. You must be at least 35 years old to be president. True. Benedict Cumberbatch is older than 35. Also true. That's good. Invalid. Because just because you have to be over 35 to be president doesn't mean that you're automatically the president when you turn 35. So it's a necessary but not a sufficient condition. You also have to win an election, of course. Okay, good job. Okay, so that's all good information for question 7. So then we are going to, oh no, sorry, that was question 6. So 7 is yet one more. An invalid argument with a false premise and a false conclusion. What's one like that? False premise and a false conclusion, and the whole argument overall is not valid. Like what? So false statements that don't even imply another false statement below. So Arlene, cherries are vegetables, all fish are blue, and therefore 2 + 3 = 7. Okay, yeah, so it's definitely invalid. And yeah, that's a perfect example. I mean, your conclusion is logically false, so it has no potential to be true. And the premises are false statements, but even if they were true, they would coexist with a false conclusion because the conclusion is logically false. So that's okay. Maybe an example that doesn't involve a logically false statement or a logically true statement, just like regular false statements. Okay, so Jamie, Kobe is alive. We're in a pandemic, and therefore I'm the president. Good. That's totally invalid because Kobe being alive now and being in a pandemic would not have any implication about you personally being the president of the US. So it's an invalid argument because the logic of the premises does not imply the conclusion. Furthermore, there's a false premise, the first one, and a false conclusion too. Okay, good. So we're going now to the next batch, which is 8 through 15. And they're asking you for examples which fit the instructions of the question. In some of these questions, there's no example that can be given. But for most of them, you can give such an example. So let's go over the 8 through 15. Question 8. So a consistent set of statements, but in which one sentence is true and another is false. Let's give an example like that. So a set of sentences that could all be true together, but it's just that in fact they're not all true. Like what could be one such case? And I'll just work with whatever comes up in the chat. Yeah. What do you have? Let's see it. Okay, so I'm looking here at your suggestion, Arlene. It says, Michael Jackson is alive. Donald Trump is the president. Alligators are reptiles. Okay, good. That's fine. That's perfect. That's a consistent set of statements, but they're not all actually true. So Trump is Trump is the president. Yes. Alligators are reptiles. That's also true. And Michael Jackson is currently dead, but the statement that Michael Jackson is alive is compatible with those other two statements being true. It's not incompatible or logically contradictory to them. So all those things can simultaneously be true in a given possible world. That's exactly the right answer. Okay, so Lily, Kobe Bryant passed away in 2020. Hillary Clinton became the US president in 2016. Yes, perfect. So Kobe Bryant did pass away tragically back in January, as we all know, and Hillary lost the election. So one statement is true and one is false, but they're consistent with each other. There is no contradiction between those two, and they could have both been true had things played out differently. Valeria, Trump is president, Nancy Pelosi is vice president. Now, just knowing about their political views and overall ideology, it seems almost impossible, but theoretically, of course, this is conceivable. It's conceivable that there's a world where they had chosen to run on the same ticket and become, the two president and vice president. But one is false, clearly, and one is true. Drown Red, my field class starts at 11:30. The class is in person, and the class is provided by Cal State Fullerton. Yeah, those could have all been true, but of course it's not in person, so the one statement out of 3 is false, but they're all consistent. Good. So let's go to number 9. A consistent set of statements, all of whose members are false. So consistent sentences, but they're all not true. What do you think? What do you have for that? So it's kind of like the previous examples given here by some of you, except you just have to dream up examples of all the statements that are not true, even though they could have all been true at the same time, in the same world. So what's a couple of sentences that are compatible with each other but not all true? Okay, Hillary's president, Kobe's alive. Yeah, both false, but both could have been true, and there's nothing about one being true that would cancel out or contradict the other one. Lily, the Berlin Wall was built in 2010, and a huge fire wiped out the entire human population on Earth in 2014. Well, thankfully, the second thing didn't happen, although we've had some pretty big fires. And the Berlin Wall was built way back in the Cold War era. So yeah, anyway, good. Both false, but within the realm of possibility that they could have each been true. John lives next door to Sandy. Sandy lives 2 blocks from John. Well, Valerie, that's a strange example. There's no such people as John and Sandy, so who are you talking about? I can't evaluate these statements as either true or false unless they're actual facts. So you can't use invented names like we're talking about storybooks or something, or like make-believe. When it says true or false, it has to correspond to the world or not. So unless you know somebody named John and Sandy, I can't possibly tell what you mean. Maybe you have to give last names of real people and talk about their actual whereabouts. But yeah, do you understand what I'm saying, Valeria? The question is that they have to be false, even though they're all consistent. But your statements are neither true nor false, because John and Sandy are just made-up people. That's why we keep talking about like actual human figures and so on that we all know about. Furthermore, they're not even consistent. The statement says consistent set, all of whose members are false. But your example kind of fails both criteria, because they can't evaluate their truth value since they're not real people's names. And then the second thing is they're inconsistent, because it says John lives next door to Sandy and Sandy lives 2 blocks from John. So which one is it? Is it next door or 2 blocks? It can't be both, because 2 blocks is not next door and next door is not 2 blocks. So this is an example where the statements are inconsistent. All right, so let's go to number 10. Question 10, logically true sentence. That should be easy enough. What are some examples of sentences like those? A logically true sentence. Triangle has 3 sides, good. Anything that's a fact from geometry or math or trigonometry, you know, just stuff that's formal and formally defined is going to be logically true. Hexagon has 6 sides, good. Pentagon has 5. So you guys are going with geometry examples. It could also be math. 2 + 2 is 4. Square root of 9 is 3, etc. Okay, good. Logically false sentence. You remember those kind of examples? Logically false sentence would be like what? To say that a rectangle has 3 sides is logically false, good, because it's 4-sided polygon. Blue and red make the color green. Sorry, Frida, is this for logically true or logically false? I think blue and red do make green. Is it logically possible that they could have created a different color had the facts about the electromagnetic wavelengths of light spectrum been different? I mean, that's a kind of far out possibility, but I would grant that it's probably logically true. Okay, Evelyn, I am both 13 and 20 years old. Exactly, that's logically false. That can't be the case. And sorry, Frida, now I'm confused. So I don't know enough about the primary colors. Those lessons have been way buried in my memory. Red and blue make what, purple and not green? And so, yes, thank you for the help. Well, anyway, not knowing enough about the primary colors and how they combine. But I would also be a bit skeptical because concerning color, which is a property of the effect of light on your visual system, it seems possible to me that there could be some subjectivity in the experience of it, even though I know that the nanometer spectrum of which a normal frequency of color occurs on this electromagnetic spectrum is something that's defined and known. But anyway, yeah, 2 + 2 = 5, that's logically false. Being 13 and 20 at the same time is not possible, that's logically false. Okay, good. Logically indeterminate sentence. Go ahead and put one of those out there. That's for like question 12. It's logically indeterminate. That would be like really just any random statement that could have turned out either way. Okay, you're sitting down, Arlene. I don't know if you are, but I assume probably watching a lecture like this you are. But if you stand up for a minute, it's going to be false. So it's not logically true nor logically false, because in some scenarios it will be true and in some it will be false. That's what logically indeterminate means. Drinking water. Okay, good. Maybe you are, maybe you aren't. So it could be true or false depending on the facts. That's what it means to be logically indeterminate. It has the possibility to be either way. Biden will win the election. That's logically indeterminate because it might turn out to be true or it might turn out to be false. And even looking at things from the past, Trump won the 2016 election. That's logically indeterminate because although it's true, it didn't need to have happened, and it's very well could have happened otherwise. Okay, good. Leo, I'm wearing a hat. While I'm typing, my cat is sleeping next to the laptop. It's snowing. Those are all good examples. Okay. Peachy. She gets so excited when I'm lecturing. She doesn't want me to pay attention to the lecture, but that's okay. So next up, a pair of sentences that are not equivalent logically, but they're both true. Okay. Give me a case like that. Two statements that are both true statements, but they're not equivalent. Okay, so Arlene, good. Dogs are mammals, true. Kobe Bryant died in 2020, and that's also true. But these two statements are not logically equivalent because we can envision a scenario where, yes, dogs are mammals, but no, Kobe did not die in 2020. And since it's possible for them to have different truth values, they are not equivalent, right? So not equivalent means it's at least imaginable for them to not have the same truth status. Since these two things, though they are both actually true, don't have to be simultaneously true in every imaginable world. They're non-equivalent, but both true. Okay, something else along those lines. Arlene, that was good. Anybody else? One more quick example. Pair, two sentences, both of them true, but they're not equal in terms of their meaning. They don't have the same content or information, but they are both true statements. So what could be another case? What would you say? One more. 4 sides on a square, 3 sides on a triangle. Okay, but that's not correct though, because the question says they have to be not logically equivalent, and I'm sorry to say those are logically equivalent. There are, like 4 sides on a square is true in every possible world. 3 sides on a triangle is true in every possible world. So there's no single world where one is true and the other is false. Therefore, they are equivalent. Equivalent means they could have different truth values. But since both of these are logically true, it's never going to be the case that one is true and the other is false. Does that make sense to you, Drawn Red? So I'm glad that I got your example so I can clarify that. Those two statements you gave are equivalent. The instructions say they must not be equivalent, but yet both true. So maybe one more along the lines of like Arlene's example. What could be? What could be good? Go ahead, fire away, shoot, hit me with it. Let's get that example. Put it on the table. Let's go. What's another one? Or were there so many of you that said, not possible, can't be written, no such thing? Okay, Ethan, we can see because of light, fish swim in water. Interesting, it's a fair enough example, although a little complicated. But we can see because of light, yeah, because light strikes the retina, reflected off the surface of the distant object, carried by the photon of light to your brain, and so on. So we can see because of light, that's true. Also, fish do swim in water, that's true. But suppose that, the world was different and fish, I mean, they wouldn't exactly be fish, but whatever. They don't swim in water, they like meander around near the beach. And in that world, we're still seeing because of light. So it's possible to imagine a situation in which one is true and the other is false. And since it's possible to imagine a situation where they do have different truth values, they're not equivalent statements, but they are both true. Okay, so to 14, let's move to 14. Now I'm asking for a pair of sentences that are equivalent, but they're both false. So a pair of equivalent statements that are just false things. Okay, Arlene, Donald Trump is my father. I am Donald Trump's daughter. Okay, good. Yes, those are equal. To say he's your father is just another way of saying that you're a daughter to him. Being a daughter to him is that he's a father to you. And so if someone's daughter, then it has to be true that that other person is their father. So that's true. Those are two logically equivalent statements, but they're false because obviously you're no relation to Trump, in fact. Lily, Henry Clay won the U.S. presidential election in 2016, and the U.S. presidential election was won by Henry Clay in 2016. Okay, good. Now, who's Henry Clay? Is that a real person, though? Because that would be somewhat just one little important thing to mention, because it's got to be that this is a false statement, and for it to be false, it can't be like Humpty Dumpty won the U.S. presidential election, because no such person, right? But I take it on your word that there is such a person. Any two logically true sentences are logically equivalent? Yes. And any two logically false sentences are also logically equivalent, correct. So like 2 + 2 is 4 is logically equivalent to there are 3 sides on a triangle. Yeah, because they're both true in every case and never have a different truth value. Okay, good, Lily. So Frida, I'm older than my dad and my dad is younger than me. Okay, good. Those are definitely both false and they're logically equivalent statements. Yeah, being older than a person means that that person's younger than you. So that's what the equality is coming from. But clearly the falsehood comes from just the fact that you're not older than your dad. Okay, good. So question 15. A pair of sentences that are equivalent, but one is logically false and the other is logically true. What do you think about number 15? What do you say to our question of 15? So you got 2 sentences, one's logically true, one's logically false, but they're equivalent. Is this possible, impossible, or what do you say? To question 15. Good, exactly, love it. Cannot be given. There's no such possible example. And the reason for that is because equivalence means they have to have the same truth value, meaning if one's true, the other one has to be true. If one's false, the other has to be false too. But when one statement is logically true and the other's logically false, they will never coincide with their truth value, not even in one case. Because if one's logically true, it can never be false. If one's logically false, it can never be true. And so they're going to have divergent truth values and they can never coincide. If they were equivalent, they would always coincide. Okay, perfect. And Arlene, you say that, I think. You say example can't be given because the definition of logically equivalent is that it's not possible for one sentence to be false while the other is true. Exactly. Good job. Okay, so now with 16 and 17, some straightforward questions. 16 asks this: is this a consistent or inconsistent set of statements? And just tell me why or why not. So it says, Henry likes real ice cream, statement 1. Statement 2, real ice cream is a dairy product. Statement 3, there is not a dairy product that Henry likes. Are these consistent or inconsistent? So you heard it. Henry likes the ice cream, and that's dairy, and Henry does not like any dairy product. Good, Arlene. Logically inconsistent because the statements contradict each other. Right, the first 2 statements contradict the third one and vice versa. The third one, just looking at it, says he does not like dairy. But the first 2 say he likes ice cream and ice cream is dairy. So they can't all be true. If the third one is true, then the first 2 are false. And if the first 2 are true, then it's also false that he does not like any dairy product. Okay? So that's contradictory. Basically, one is saying he likes dairy and the other is saying he doesn't. That's not consistent. Okay, 17. Sue is taller than Tom. Tom is taller than Henry. Henry is just the same height as Sue. Is this consistent or not? So Sue is taller than Tom. Tom is taller than Henry. And Henry is the same height as Sue. Good, Arlene. It's inconsistent because they cannot all be true. I mean, you could say a little more, though. That's just the definition of inconsistency. But in this specific example, why can't those statements all be true? Well, because it's about height, right? And suppose that Henry and Sue are the same height. If they're the same height, then how is it true that Sue is taller than Tom? Because Tom is taller than Henry. So if it's true that Sue's taller than Tom and Tom is taller than Henry, then Sue should be taller than Tom. But the third statement says that they're the same height, which is impossible. So one of these statements is not true. They can't all simultaneously be true because they contradict. That's good. So now to question 18 and the last 3. The last 3 are about equivalence. So there's a pair of statements, and the question is, are they equivalent logically or not? So here's one question. These 2 statements. Henry is in love with Sue. Sue is in love with Henry. Are those logically equivalent or not? Henry loves Sue. Sue loves Henry. A pair of equal statements, or are they not equal? Okay, love it. They're not logically equivalent. Good, and that's correct. They're not logically only one. It could be true that just one loves the other and the other does not love them back. So 2 people loving each other mutually is possible, but it's not guaranteed. Therefore, we can certainly imagine a situation where the love is not returned. If that's the case, then one of the 2 statements would be true while the other is false. And since that possibility does exist, it's not equivalent statements. Number 19, Sue married Barbara. Barbara married Sue. Are these 2 statements logically equivalent or not? asking about 19, the marriage question. Good, Valeria, those are equivalent, yes. And what's the difference between 18 and 19? Well, 18 speaks about a relation of mutual love, which is not always guaranteed to come back. But 19 is talking about marriage. So suppose that some person marries somebody else. It's not possible for them not to marry you back. So either we're both married to each other or we aren't. But there's no situation where I'm married to you and you're not married to me. So marriage implies that both parties to the marriage are in that marriage. Therefore, 19 is a pair of logically equivalent statements. They're saying the same thing. If I say Sue married Barbara, that means the exact same thing as Barbara married Sue, unlike with question 18. Okay, now, the last one is 20. And 20 says, I know there are people who are starving in every large city in America. And then after that it says, in every large city in America, I know people who are starving. Are these equivalent or not? What do you think on these? The last one. I know there's people who are starving in every city. And also in every large city, I know people who are starving. Okay, good. Not equivalent. Why not? Let's try and get the explanation. That's right, they are not equivalent. But for what reason? Why is it that you see and you judge that they're not equal statements? Okay, good. So Evelyn, not equivalent because you know that there are you know that there are people who are starving in every large city in America, but that does not mean that you know specific people in every large city in America who are starving. Yeah, correct. So I could know as a general fact that in every big city, Chicago, New York, Los Angeles, Philadelphia, Atlanta, in every major city, I know there's homelessness. And so there's people starving and hungry in every major city. Maybe I know that as a fact, but that does not mean that I have personal knowledge of specific people in each city that are starving, which is what the second statement says. So I might not know any people that are starving, like I don't know any such people personally, but I know that they do exist in every city. So one of the statements could be true and the other one could be false. Okay, good. So guys, that's just a rundown of the first homework. Now that we've covered that, I think we probably have really good knowledge and insight as to the correct answers, and we'll just carry that with us through as we go forward in some other meetings. What I'd like to do now with the rest of today's class period, if I can, is to try and switch us over to, okay, Lily, question, let me get your question. If two sentences are logically true, they must be logically equivalent. Yes. If they're just regular true, indeterminate, they're not necessarily equivalent. Exactly, correct, yeah. Like, I'll give you another case where there's two regular true statements, but they're not equal. I teach at Cal State Fullerton, and you're a student at Cal State Fullerton. Those two statements are both true, but they're not equivalent. Because like if you dropped out and you, let's say, go to a different school, then I'll still be a professor here and you won't be a student here. So that shows the possibility, even though it's not happening right now, the possibility is there that one could be true and the other one false. So they're not equal in meaning. Equal statements means, again, just to repeat, they cannot have different truth values. So asking whether they can or can't requires that you think not just about the actual situation we are in, but other possibilities where their truth value could diverge. If it's a possibility that they could have diverged in a counterfactual scenario, then that counterfactual scenario will expose that they're not equivalent. Okay, so very good, yes, thank you. Okay, so I want to go back then to more of our symbolization. I'm just going to get keyed in on that for the remaining part of today's meeting and then part of Wednesday's meeting too. So I have here a little link that I would like you guys to use so that I can display some of the stuff that's in our book and from the answer key for the book on the page by doing the screen share. So here's a Zoom link. You see the link, and I think you'll be able to click on it. So I'm just going to go ahead and switch formats, but I'll allow this video to continue to play. So in fact, I'm going to be broadcasting both on YouTube Live and Zoom at the same time, but we'll switch to Zoom. The only reason I don't want to close this stream is because maybe there will be a student that arrives late to the meeting, and if that's the case, since I didn't send an announcement saying we'll meet on Zoom halfway through, then they would not be lost. So do open the Zoom link, and I will do it as well, and then we'll be right there. Since I didn't send an announcement saying we'll meet on Zoom quickly, then they would not be lost. So do open the Zoom link, and I will do it as well, and it will be right there. What's this? Okay. Whoa. Gotta move Peachy here, sorry. She's jumping on the keyboard. Saying we'll meet on Zoom quickly, and they would not be lost. So okay, yeah. So to those that are in the Zoom meeting, perhaps silence the microphone for a moment, because I think maybe some of the playback that comes forward delayed was coming into my speaker system, and then that would make it such that I'm competing with my own voice. Okay, so I see all the participants that are here. Great, guys, thank you so much. I'm gonna just pull the chat bar over here to the right, and then let me share the screen. Yes. No. Okay. Every time I do this, I always lose sight of the chat at first, so just give me 2 seconds. Yeah, there it is. Okay. Line this guy up, and I guess I'll put it over here to our left. Now, minimize this for a second. Okay. The logic book. Here we go. Sorry, no, not that one. Oops. Here it is. Now, if I remember correctly, we were looking at this set of problems. Isn't that right? 2.3. Let me know over here in this chat if you can see this and if you recall that we were working through this problem set. Now, okay, good. Can anyone give me a quick heads up as to which problem, if you've taken clear notes, might have been the one that we left off with? And then we can just kind of go right back in. Let me know. This is section 2.3, practice problems from the book. And I think that we had reached this, but I don't want to double dip and do the same thing again. So let's see, feedback, anybody? Otherwise, I'll just start going like randomly through. We finished C for sure. Okay, yeah. Okay, so I think D then could be where we can pick up, yeah? So we're looking here at this symbolization key. These letters, these capital letters, stand for different sentences that populate the examples written here, A through J. And so we're just going to get you back into the framework of trying to translate these into our symbolic language with SL. So, by the way, can I move this thing somehow so that it's, okay, good. Cool. All right, yeah, so like here we are with our little list of questions. Let's look at D. It says, assuming the rain stops within an hour, the game will not be postponed. So you see all the sentence letters, and you know our connectives. Just as a reminder, we have this is if then, this or this is and, the tilde is for not, the wedge is for or, and the either triple bar or the double arrow is for if and only if. So let's see question D. Does everyone see it here? Yeah? Okay, so Lily, you give H arrow tilde G. And that is for assuming the rain stops, so H is for the rain stops within an hour. Assuming the rain stops within an hour, which is if the rain stops within an hour, the game being postponed is letter G. So the tilde to the left of it means not the case that. And you're exactly right. So it's a conditional statement, H, then tilde Q. So that's our letter D. I'm going to put it here on the board, and then we'll go to the next. All right, if H, then not G. In other words, if the rain stops within an hour, H, then in that case, it's not going to be the case that the game will be postponed, which is the negation of G. All right, good. So let's look at question E. You see E, everybody? It says the Indians will win tonight provided their starting pitcher can go to full 9 innings. Sorry, kind of open my video up here a little so I can see how I look to you guys. Sorry, I was trying to get it to go horizontal-wise, but now I don't know if I can. Anyway, I'll just move it way over here. Maybe that's better. Okay. Good. Yeah. So looking at question E, all of you guys, the Indians will win tonight provided their starting pitcher can go the full 9 innings. Looking at this symbolization key above, let's see who can get it into our chat. Okay, Leonard, Leo, what you wrote is for E, S arrow I. So S stands for the Indian starting pitcher can go the full 9 innings. Right, provided that the pitcher can go the full 9 innings, then the Indians will win tonight. Exactly. So you got the correct order of antecedent and consequent. What you were clever enough to notice is that where it says provided there, that means that what follows this is the antecedent that would cause the resulting consequence of the Indians winning. So you're exactly right there, Leo, for E, as you wrote S arrow I. Okay, so let's keep going, and we'll look at F. F. The Angels will move into first place only if the Twins and the Indians both lose tonight. The Angels will move into first place only if the Twins and the Indians both lose tonight. So how can that one be structured? This one takes a little more thought perhaps at first. So where will we start? Starting with the left. The Angels will move into first place only if the Twins and the Indians both lose. So how can this be stated logically in our language using our symbols? Let's see. Okay, so you have the N, then not the case that T or I. Okay, good. I think that looks correct. I'm going to quickly scan the page again. So it's F that we're looking at. The Angels will move into first place is for N, correct. If N, then in that case, it follows that Twins and Indians both lose. So for the Twins and Indians both lose to be symbolized, we have to negate that they win, which is what letter I and what letter, T stand for. T stands for Twins win, I stands for Indians win. So those need to be negated. There's two ways that that could be done. One is the way that Lily has chosen, which is to have a tilde outside of the disjunction, which means it's not the case that either T or I. Okay? There's another logically equivalent way to phrase this proposition in logic. Does anybody think they know how this could be also worded in the consequent? Oh, sorry, what in the consequent? Let me look at this. No, because look at F there, Leo. We're looking at F, isn't that correct? F says only if the Twins and the Indians both lose tonight. So the reference to the Angels is not there. The Angels moving into first place is the antecedent, which is the letter, yeah. So Leonard, when you have only if, you read the statement that is to the left of the term only if as the antecedent. And you read the statement that follows to the right of only if as the consequent. Now, if the word only was not attached and it just said if, then it would be like in the previous example where you treat the thing to the right of the word if as the antecedent. But having only with it means that we just read it left to right as normal. So the left part, the antecedent part, is the part of the statement that stands for the Angels will move into first place. And the Angels moving into first place is N. If N, then not the case that either the Twins win or nor the case that the Indians win. But I'm asking if you guys can quickly give me a reformulation of this, which means the same thing. So this is a correct answer, but there's another logically equivalent way to put it. And here's a hint. It has to do with the consequent clause here. Lily, you seem to already have it, and that's right. So we could have also put it this way. N arrow, and without the parenthesis, simply, or actually left parentheses, tilde T and tilde I. So like these two things are equivalent. Not either T or I is the same as both not T and not I. Like, so if I told you that neither Trump nor Biden will win the election, that would be like this, tilde T or I. And if I wanted to say he won't win and the other guy won't win, then that's the same thing, and it's just like this. Both the case that not Trump and not Biden. So when we said, as F says, only if the Twins and the Indians both lose, there's two ways to say the Twins and the Indians both lose. We could say neither one wins, or this one loses and the other one does also. Okay, so that's for F. Let's go on then and move to letter G. Okay, so letter G says, assuming either the Twins or the Mariners win tonight, the Royals will be out of the running for the pennant. So let's try to rationally reconstruct that in our language now. You see the statement in English. Assuming either the Twins or the Mariners win tonight, assuming that, then the Royals will be out of the running for the pennant. Using our sentence letters and symbols, let's get that one written down in one string from left to right. Assuming either the Twins or the Mariners win tonight, how can that be written down? T or M. Okay, good. So T is Twins win, Mariners is Mariners win. So either T or M, assuming either one. So if we assume this, then what? Assuming either win, then Royals will be out of the running for the pennant. And how do we say the Royals are out of the running for the pennant? Well, R stands for they're in the running, exactly, Leo. And so we would simply negate that, and that would be tilde R, which stands for it is not the case that the Royals are in the running for the pennant. So this is our statement for G. If either T or M, then in that case, not R. If either the Twins or the Mariners win, then the Royals will not be able to run for the pennant. Okay? So far, so good, everybody. Let me know if anything needs clarification or if it makes good sense. I'm just trying to help you with these problems so that we're all good with symbolization. So if that's fine and well, let's move on to the next, which is H. Okay, so the Red Sox have a good chance of winning the pennant if and only if the Mariners and the Angels and the Twins all lose tonight. Okay, so this one's going to take a little bit of steps, but let's just work it from left to right. So starting with the Red Sox have a good chance of winning the pennant. That's which one again? G. Okay, good. So up here, get more space. Letter H. So G is the first thing. It says the Red Sox have a good chance of winning the pennant, and that's what G stands for. But it continues by saying if and only if. So what's the symbol for if and only if? Let's just get that out there. The if and only if symbol is designated as the what? The double arrow or the triple bar. Okay, so double arrow, if and only if. The Red Sox have a good chance of winning the American League pennant if and only if. Now we have to have over here this information to the right. The Mariners and the Angels and the Twins all lose. That means all lose tonight. So what we have, according to you, Andre, good, is not M and not A and not T. Good. And Lily, one extra thing that you added, which is needed, is the additional bracketing to correctly group the conjunction to the right as having two terms. Right, perfect. So it's going to be like this, tilde M-A-T, so tilde M and tilde A, and tilde T. But we have to place these within the proper type of parentheses. So to do that, we have to turn this into a binary where there's this component to the left, which is itself conjunction, and this component to the right, which is a negation. But to make it clear that this entire expression is the right hand of this biconditional, we have to place another set of outer brackets around the full expression. And then it looks as follows, exactly how you have it there, Lily. It would have also been okay to have grouped the second right-hand parenthesis here, and then we would have had the case of left, right, right, right. So the rule here when it comes to parenthetical bracketing is that you have to have an identical number of left-facing as there are right-facing parentheses, because each left-facing parenthesis has to be closed by one on the right. Otherwise, it's not syntactically correct. So here we have left, left, 2 of them, and here we have right, right, another 2 of them. Had it been different, had we wanted to state it somewhat differently, I think, well, no, I don't want to do it that way. Yeah, let's just stick with this. This is a correct formulation of it. All it was trying to say is that you could have also done this. It's also like this could have been your option, right? Because it's irrelevant how you group 2 out of 3 in this part of the expression. So they could have been grouped 2 to the left and 1 on the right, or 1 on the left and 2 to the right. The order of the bracketing is not really too important when it comes to conjunction, but the main thing is you have to have as many left-facing ones as right-facing ones. So these are both accurate ways of paraphrasing. Why do you need 2 parentheses? Good, okay, and Andre. Because without the second parentheses, like say we just had it like this, we would not know what the main connective of the formula is. Is the main connective the and symbol here? Or is the main connective the biconditional symbol here? It's supposed to be the biconditional symbol because that's the first thing that is read when you read the English original version of the written statement. It says, the Red Sox have a good chance of winning the pennant if and only if. It doesn't say and right there, in which case we would interpret and to be the main connective. So the main connective is this biconditional symbol. That means that it has to have 1 term to its left and 1 term to its right. So by placing the whole formula here to the right within a larger group of parentheses, we show on the page that this entire formula is the right-hand term of the biconditional. Without those outer parentheses, we would not know whether this is to be interpreted as all of this information and tilde T, or this information if and only if this. Since the English original is read as an if and only if statement, this makes that clear by grouping everything to the right of the double arrow in one big bracket. Without the brackets, we basically don't know whether this is to the right of G, or whether it's this, or whether the conjunction symbol is actually the main connective. So we have to eliminate the ambiguity there, and the brackets accomplish that. No problem, yeah, and I know it's like one of our first times using a little more complex bracketing, but as we practice it and do more examples like this, it gets easier as we proceed. And Brenna, good question to you also, from you also. The order of M, A, and T is not necessarily relevant. I just put them in that given order because it matches to the English. But with the conjunction of 2 facts, it's not relevant which order they come in. So like, for example, I'm wearing a watch and I am wearing glasses. Now let that be a conjunction, W and G. Vulich is wearing a watch and Vulich is wearing glasses. I could have said it opposite and it would have the same exact meaning. So that's logically equivalent. The statement W and G is equivalent to G and W. Vulich is wearing glasses and he is wearing a watch. So I could have ordered it with W first or G first, and it would convey the same logically equivalent fact. So good question. With conjunction, and also with disjunction, it's not really important which side to the left or right the individual sentence letters are. Okay, good. So quickly unplugging in my computer to the charger, running 2 streams at once, it eats so much battery. It's crazy. Taking down from like 60% to 20 in 30 minutes. Okay, so back to these listed questions. Let's try one more, I guess, with our time remaining, or if we do have a chance, maybe we'll get to I and J. But anyway, for letter I, the Royals are out of the race for the pennant, and the Yankees will win the pennant if and only if the Twins win tonight and the Mariners and the Angels both lose tonight. So this one's a little bit of complicated also, but we'll take it step by step. So first thing to notice is the main connective, where it says the Royals are out of the race for the pennant and the Yankees will win the pennant. If and only if. So if and only if is what occurs right after this expression is stated. If and only if is thus the main connective. So we know that we're going to have, for letter I, a biconditional symbol, and there's going to be stuff to its left and stuff to its right. So what is to the left of this if and only if? How can I symbolize for the part of the formula that says the Royals are out of the race for the pennant and the Yankees will win the pennant? Royals are out and Yankees will win. How does that get written? So Royals out of the race for pennant. Okay. Not R is for not in the running. Good. And conjunction symbol, ampersand sign. And Yankees will win the pennant, and that's just letter Y. Okay, good. So those two things, if and only if what? That conjunction is true if and only if the Twins win and the Mariners and Angels both lose. So how do I have the statement to the right now? Focus just on this right-hand side. Twins win, Mariners and Angels both lose. How can I write those things down? So Twins win is T, and the other team's losing is not M and not A. And once again, as before, we have to make sure that everything to the right of this expression is properly grouped. Otherwise, we would not know whether it is T that is being joined to this expression with a conjunction being the main connective. So now that we see that this entire formula to the right is grouped within brackets, it makes it clear that this is our main connective. And that's exactly right. T and not M and not A. Or, alternatively, we could have said T and what? Tilde, and then within parentheses, M or A. Exactly, Lily. So that would be the other alternative. And that's something that you should try to remember if you can. That, like, for example, these two expressions, not A and not B, is logically equal to not either A or B. So when you have a tilde that occurs outside of the scope of a disjunction, it can be distributed through and then have the conjunction sign replace the disjunction symbol. And likewise, this, not A or not B, either not A or not B, is equivalent to the statement that not both, A and B. So to say that, like, it is not the case that both Trump and Biden will win, letting A stand for Trump wins and B stand for Biden wins. It's not the case that they'll both win, which is obviously true, because we're only going to have one nominee that wins the whole thing. Not both is the same as saying either Trump will not win or Biden will not win. Okay? Now to say neither nor, like meaning both cases won't happen, is equivalent to saying not the one and also not the other. And so over here, where we have the statement in grouped within parentheses that so just showing you, like, the only difference between these two formula is that here we've replaced both not with not either. Okay, so that's just another way of doing that. So I guess when we return next time, we'll go over a few more of these remaining complex symbolizations, but you're well on your way and you're doing a good job. One thing I'd like for us to try in some of the practice work that we do next time is the stuff here in 2.3.5, because that's where you're actually symbolizing arguments, and that's also important, not just individual sentences, but arguments. So we'll take a look at the problems here in 2.3.5, and then also 2.3.6 has some of the similar kind of problems where you're translating whole arguments into the logical language. Then after we finish with that stuff, the next thing coming up are truth tables, and so we have some more lecture on that. But for now anyway, it's all about symbolization. So if you've been tracking the lessons, keeping up with the book, you should be in decent shape. But I'll send the new homework problem set out later tonight, or latest tomorrow early in the morning. And then you'll have until 2 weeks from today, so that's the 5th or whatever, until the 5th to finish it all up. So okay, I guess is that good to go? Any questions for me of any kind? Let me know if so, or if everything's all right. Then just tell me in the chat that we're all good. And I guess I'll just see you guys at the next meeting on Wednesday. Remember, I have office hours today, as I always do Monday and Wednesday. So it's always an open invitation for anyone that wants any help or any comment. Okay, guys. Well, good. Good to hear from everybody and see you guys. I'm going to end both streams. So right now I'm ending the Zoom, and then I'm going to click over to the YouTube and end it too. So thanks, guys, and I'll see you back on Wednesday then. And let me know about your score if you would like, and I'll send it to you. Just give me like a day or so max to finish and reply back to your message. Okay, thank you. Bye-bye. And the YouTube, we're still over here. All right, guys, so closing this one too. Thanks again, and I will see you on Wednesday on YouTube. And if I want to open a Zoom meeting, we'll do it the same way as we have done, where I'll just put a link in the chat and we'll have both formats. All right, thanks again. Bye-bye.